Let's look at problem N. Okay, amen. All right, very good. Kenzie, can you say it nice and loud?
This looks too hard.
This looks too difficult. She's trying to figure out, she's like, no way, I can't do this. This is the immediate response that people have. I need you to fight that, okay? So third hour, there's definitely a lot of confusion here. I need you to open up your brains and try to look for what I'm showing you.
Wait, hold up. There you go. We're good.
A squared plus 2a quantity squared minus 2a squared plus 2a minus 3. I want to factor that, okay? I wouldn't expect you to be able to do this problem on your own, but I wanted, you guys, I could give you difference of two squares all day and you just get all the problems, right? Let's try something that you maybe can't do and expand your brain a little bit. I think that looks too difficult. I'm going to make an easier problem. Watch. U squared minus 2u minus 3. Look at it and see if you can tell why these two are very similar. It's something squared minus 2 times that something minus 3. Can everybody see that? Are you all okay with that? Okay, so I'm going to argue right now, if I can factor that, then I should be able to factor that. You with me? Let's factor that. Wasn't that easy? So now this will be that easy. This is going to factor the same way. Something minus 3 times something plus 1. What is that something? Right? Yeah. So that something, which is a squared, I'll just write, sorry about that. A squared plus 2a minus 3. That's the something we had. That took the place of u. Times what now? Good. Okay, hold on. Let me show you. Okay. This is that something, right? A squared plus 2a is the same thing there, right? So that's something minus 3. That's something plus 1. This thing is that. This thing is that. That thing minus 3. That thing plus 1. We good? Does a squared plus 2a minus 3, does that factor? To what? A plus 1 times a plus 1, or a plus 1 squared. Look at that. I took a super complicated problem and made it piece of cake upside down.
Where are you getting the plus 1? Because the thing of like the u squared minus 2u minus 3, which you factor first, had nothing to do with the actual problem.
Yes, it does. This thing squared minus 2 times this thing minus 3. U squared minus 2 minus 3 is the same thing as that. It's the same thing, just instead of a u, it's an a squared plus 2a. Pause, let go of it. Take out your worksheet from yesterday, and let's try one of the problems that this would apply to.
It was this one, right?
Nope.
Oh, that one that I tried to do, but I did it wrong. This. When I tried to do it, I did it wrong.
Okay, so I'm going to give you another chance to see that what I call a substitution method in order to get this right. Okay? Okay? Don't fight it. Allow your brain to be patient, okay? Take a deep breath. What happens in math or science or English or any time is as soon as you get frustrated, you develop anxiety, and it shuts down the creative portion of your brain, which doesn't allow you to see connections. So just say, you know what? Hey, it's okay. I didn't see it the first time. Hopefully I'll see it this time. Okay? We'll see. So this is similar to a different problem. I'm going to write a problem that looks very similar to this. I'm going to write it as x squared minus y squared. Everybody agree I have something squared minus something squared? Everybody okay with that? Okay, so we all know how x squared minus y squared factors, right? What does it factor to? Yep, x plus y times x minus y. So now, what I'm going to do is I'm going to factor this, but instead of an x, I put a plus b. Instead of y, I put a minus b. So let's take our time and do that. It's okay. This is challenging. So in place of x, I put a plus b plus, almost called you Sam, sorry. Your voice is very similar to Sam's. Okay, and then I have x minus y. So what do I put in place of x? A plus b minus a minus b. Okay, go ahead. What? Guys, I'm trying to listen. Can't do it again. One more time. Okay. So the key here is to now recognize you have this thing plus this thing. What do you have to recognize what's going to happen if you add these together? What cancels? B and negative b, right? So you get a plus a, which is 2a. It's all right. It's okay. It's okay. What cancels here? A's. You have b minus negative b, which is?
I don't know. Why is it an a squared? Dude, we need it on one line.
Excellent.
Oh my
So x plus x is 2x. X times x is x squared. Thank you. Excellent question. So now you have 2a times 2b is 4ab. Folks, it's okay to make the mistake. It's okay to be confused. We need more people that are willing to be confused, okay? We are all okay with doing things that come easy. We need people who are willing to do things that come difficult. Good for you for taking the difficult class. Yes. We can, after we do today's lesson, okay? So we had about 18 minutes in the previous class to work on the homework assignment. So I will go over questions that you have after we introduce the new material. Please turn your notes to the next section, 1.4. Here we go, here we go, here we go. Well, thank you. And here we go. You guys are great at simplifying rational expressions. You're going to do an excellent job on this assignment today. We want to simplify things like 54x squared over 24x. As you work on simplifying those, I want you to see why it works. Would everybody agree I could write 54x squared as 6x times 9x? And would everybody agree I could write 24x as 6x times 4? So using the property of multiplying fractions, notice that you have 6x over 6x times 9x over 4. So we often talk about this idea of things canceling or going away. When we say that, let's understand what we're saying. What is 6x divided by 6x? 1. And if it becomes 1, 1 times anything is just itself, correct? That's why that property works. That's the beautiful thing about writing things as factors. The word factor means multiplication. So let's write it as multiplication. In this situation, you can see it's already written as multiplication, isn't it? What will cancel because,
X minus 3.
yep, because x minus 3 divided by x minus 3 is 1. You're now simplifying 8x squared over 4, which is 2x squared. Excellent job. As I look at letter C, notice how the temptation for some people might be, well, I'll just get rid of the x's. And I'll do 20 over 40, which is a half. And 5 over 10, which is a half. See how people are tempted to maybe do that?
Yeah.
We can't start canceling things off or reducing until we write it as factors. What can you factor out of the top? 5 times x minus 4. What can you factor out of the bottom? 10x. You're left with x minus 4. What now? 5 over 10x becomes? Excellent job. Letter D. I fortunately have these x squares that I could just cancel out right away. No. You must write it in factored form. That is totally illegal. You're catching on to my tricks. I'm going to have to get better. Do you like my sneakiness? You don't want to be led astray, do you? Yeah. Don't want to be deceived. All right. Don't know how to math. As you can see, the x minus 3's will cancel. I have x plus 3 divided by x minus 2. Can I cancel off the x's? No, they're not written as factors. Good job. You must have had a really good Algebra 2 teacher. I'll go give her $1. 3 over 2x times 4x over 9. When you are multiplying, we multiply straight across, but you can cancel across from each other ahead of time. So what will reduce ahead of time here? 3 over 9 reduces to 1 over 3. 4x over 2x reduces to 2 over 1. So now take what results and multiply it, get 2 over 3. Yes. Would you mind asking in case somebody had the same question?
Yeah, I was going to ask why it's 1 over 3 instead of 1 over, like you know how it's 3 over 2x?
Yeah.
I was asking how you...
Got it. So you see that's the 1 over 3. Okay, excellent. Thank you for asking. All right. Here you can see that the x plus 2's will cancel. And the 4 over 12 reduces to 1 over 3. So I have x minus 1 all over 3. Please try C and D on your own. Some people say they love this stuff. They love to cross things off. It's like their favorite thing of math. I offered Jaya during third hour, I said that for Christmas, I would give her a worksheet of many of these problems. And she said, thank you very much, because she loves to cross everything out. If you're that kind of person, I encourage you to make lists during the day, and then you would really enjoy crossing off those lists. Right, unless you're a procrastinator or not productive, then you'll just feel bad about all the things on the list that are still there.
I'm usually not a procrastinator, but lately
I'm going to try to work slowly behind you. Please check with your partner or peers around you to see if you got the same answers. All right, I have this factored. For the first one, I get 3 over x minus 5. For the next one, I get x minus 1 over x plus 1. Are there any questions there? You're excellent at this skill, aren't you? Good. The more difficult part comes tomorrow, okay? How do I divide rational expressions? Good. By the oppositipical. Yep. Multiply by the oppositipical. Multiply by the reciprocal. And when we do, you can look again to cancel across from each other. So 12 over 3 will reduce to 4 over 1. Good. 1 over 3x. Excellent job. Sometimes I like to try to save space. If you notice, I'm a very cleanly person. I keep my desk nice and orderly. Nobody has commented, like every day I work it a little bit more. It's getting better, is it not? That area over there is improving. I am working on it. I'm getting better.
How did you get there in the first place? Yeah.
Some of it. So as I try to save space, what I do is I change this to multiplication, and I write it as x times x plus 1 over x minus 2. So instead of rewriting everything, I just kind of write times and flip. Okay? You see that? That saves me some space. Notice the x minus 2's cancel, the x plus 1's cancel, and I am left with x times x plus 2. X squared plus 2x, and that are the same. If the directions were right in factored form, then you would have to write it like that. But these are the same. One is not more simplified than the other. Either one is fine. Flip it over. Try the next two on your own. Go. Okay, here we go. So we have x plus 1 times x minus 1 over x plus 3. And then you should have x plus 3 times x minus 3 over x plus 1. And so the plus 1s will cancel, plus 3s will cancel. The quantity x minus 1 times the quantity x minus 3. Again, you can leave it in factored form. You don't have to multiply it out. The second set, x plus 3 times x plus 1. On the bottom, you should have x plus 4 times x minus 2. Times, on the top, you'd have x minus 2. And on the bottom, you have that beautiful 3 times x plus 1. And the 3 is there. It kind of hangs out there. A lot of people forget about it. Don't forget about it. Those cancel. Those cancel. And so you have x plus 3 over 3 times x plus 4. Can you see that some people would be tempted to cancel out the x's and the 3's? Okay, so again, that's that piece of you have to know that you can't do that. We go to the last part, which is adding and subtracting rational expressions. In order to add or subtract fractions, you must have common denominators. What would the common denominator be in letter A? It would be 6, so I will multiply the top and bottom by 2. And I get 6x minus 10 over 6. And I get 8x minus 1 over 6. Add them together, and what do you get on top? And then on bottom, 6 plus 6 is 12. Nope, 6, right? Yep. When you're adding and subtracting fractions, the denominator stays the same.
So, he did see me. I had 6 written down. I was like, oh, yeah. I literally oh, yeah, you add, right? Like a
Okay. In the next situation, are the denominators the same? They are. So you know your new denominator will be x plus 4, and your top will be 2x minus 3. You can't combine those, so you just write as 2x minus 3. So here's where we start to get a little bit more complicated. What about letter C? Okay, you can multiply. Can't I just subtract 1 from each part?
That's what I was saying.
Okay. All right. Thank you. Thank you. So let's just go to that for a second here. 3 over 7 plus, say, x over 6. If you were going to create common denominators, you couldn't just add 1 to the top and bottom, right? I mean, that's not what we do. You would create a common denominator of 42, right? So that's why we have to multiply by that other piece. Good. We learn from our mistakes.
You were so really bad at what I'm talking about.
So notice you have 2x squared over that x times x minus 1.
Over x squared minus.
You
X squared minus X.
you don't have to multiply it through. You can leave it in factor form. It's up.
Why don't we have to take it apart again?
Okay. Thank you. Let's get to your point here in a second. Okay. And then plus 3x minus 3 over x times x minus 1. So the reason why we like to leave the denominator factored is in case the numerator would cancel with something in the denominator. But you can multiply a denominator if you want to. Does anything combine together for like terms? It does not. So we have 2x squared plus 3x minus 3. And then in that denominator, we have x times x minus 1. If you'd like to multiply, get x squared minus x, that's fine as well. Either way is fine for an answer.
Okay.
For our last problem, should I multiply top and bottom by x squared minus 4?
No, you can do the other stuff.
Good. So everybody has seen that this factors to x plus 2 times x minus 2. So because this bottom factors to x plus 2 times x minus 2, I simply need to multiply top and bottom by x minus 2. So we have 5 over, I'll write x squared minus 4 just to be different this time. And then it's minus 6x minus 12 all over x squared minus 4. So just careful with your subtraction signs. What are the terms I could combine here? 5 minus negative 12 gives me 17. Positive 6x or negative 6x? Negative 6x over x squared minus 4. And that's your result. You could put negative 6x plus 17.
Wait.